Algebras. Welcome to your Chapter 11, Lesson 3 notes for Day 1, where we are going to graph quadratic functions again. So, of course, we're revisiting the stuff that we did back in Chapter 3 when we were graphing our functions in general. And we're going to rely heavily on our graphing calculator, but now, of course, we know how to find the axis of symmetry and the vertex algebraically, how to identify just looking at the equation again, whether this will be a frowny face parabola or a smiley face parabola. And now we know why I used to say that back in chapter 3, frowny face versus smiley face, right? Because positives go smiley face and negatives go frowny face. So those things kind of come together. But now we also understand what the zeros really mean. When the parabola is touching and crossing the x-axis, now we understand, based on chapter 8 and chapter 10, that is when y is 0, the answers for x. And if they are integers or rational numbers or irrational numbers or don't exist, not real numbers. And so now that kind of all starts to come together, right? So let's again use our graphing calculator to do this. Before I even start with my graphing calculator in my head, I'm just going to algebraically find the axis of symmetry. And I say in my head because x equals negative b over 2a is the equation for the axis of symmetry, right? So the negative of b is negative 4 divided by 2 times 1. Negative 4 divided by 2 is negative 2. So x equals negative 2 should be the axis of symmetry equation. Let's make sure using our graphing calculator. So for now, I'm just going to make my graphing calculator a little bit larger so we can see the screen. Press y equals, and I've got my function equation right here, x squared plus 4x minus 5. So I enter that into y1. I press graph to see it. I can already see that x equals negative 2 is going to be the equation of my axis of symmetry, the line that cuts my parabola in half, right? I can also see what my zeros are, right? So where the parabola is touching and crossing the x-axis. I can also see what my y-intercept is. That was one of the other things that we used and plugged in, right? An x value of 0, and what was the result? Oh, this number at the end, this negative 5, gives us our y-intercept. So we know so much more now than we did back in chapter 3 when we just took a table from a graphing calculator and put it on our graph. So now let me just press second and graph. Speaking of table, here's my table of points. This one just happens to be right around where I need for graphing this parabola. Okay, and I hadn't reset my graphing calculator, so I kind of wonder if I had just graphed this on something else. But here we are. Let's copy down our values, and then I'm just going to use another color to identify those values. All right, so let's do the points that actually fit on this graph. Negative 6, 7 would be my first one that fits on a 10 by 10 grid. And then I've got negative 5, 0. Again, just copying these off my graphing calculator. How about I just keep going with my x's? And we know that x equals negative 2 is the axis of symmetry equation, which means that it's matching y value. Negative 2, negative 9 is my vertex point. Okay, kind of redundant to say vertex point, but there it is. 1 all the way to 2. Okay, it's because 2, 7 is kind of the maximum back I can get going back the other direction. And so let me just keep going with my points. Negative 5, 0. Oh, that's a root. Negative 4, negative 5, negative 3, negative 8, negative 2, negative 9. That's my vertex. And then I should be swinging back the other direction. Negative 1, negative 8. Yep. 0, negative 5. That's the y-intercept. 1, 0. That's another root. And 2, 7. So let me use another color just to identify all of the roots and the y-intercepts and the turning point and the x-axis, or excuse me, and the axis of symmetry. So the axis of symmetry, of course, x equals negative 2. The vertex is negative 2, negative 9. The roots or zeros are -5, 0, and 1, 0. So those are rational roots. And then my y-intercept is 0, -5. I believe those are all the things that I kind of was pointing out in lessons 1 and 2. All right. Well, let's get them on the graph, and then I'll label them on the graph as well. So now that I've used my graphing calculator for what I needed to, it's off to the side. And let's get these points on the graph. So -6, 7, 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 0, -5, 0, excuse me. -4 down 1, 2, 3, 4, 5 to -5. And then -3 down to 6, 7, 8, and -2 down to -9. And then we scooch back up, and these values that we had just talked about as being specific points on this graph now lining up, matching up, connect. I'm going to label my equation, and then I'm going to label all the, parabola properties that we have. So arrows at the end there. Arrows at the end there, and this is y equals x squared plus 4x minus 5. Always label the equation of your function on it. The axis of symmetry is, of course, a vertical line that cuts our parabola in half. So the axis of symmetry equation is x equals -2, and the vertex on here is -2, -9. It's a point, right? So both x and y coordinates. The y-intercept is right here, and the y-intercept, of course, is 0, -5. So that's the only place where the x value is 0. And then we've got our zeros or our roots. And I'll use r for roots because that's just what I'm accustomed to. -5, 0, and another root is 1, 0. There are all of the pieces we should be able to identify. Okay. What are the zeros for the quadratic function? Well, let's start answering those pieces, right? The zeros are -5, 1. And I'm going to go ahead and put those two answers for x in French curly braces because those are answers for x. They are not coordinates themselves. If I want the coordinates, it's -5, 0, and 1, 0. So that is the other way you can answer this question. -5, 0, comma, 1, 0. Okay, that is the other way you could answer that question. What is the axis of symmetry of the function? Well, we did that in our heads algebraically, but then we confirmed it graphically that x equals -2 is the equation of the line that cuts this parabola in half. Lastly, over what interval for x is the quadratic function increasing? So this is an interesting concept, as we know, the whole increasing, decreasing intervals. And since a parabola, a quadratic function, has a distinct bottom or a distinct top, we base this on the x value that is our axis of symmetry x value, which in our case, in this example, is -2. So for the x values that are smaller than -2, is the function increasing or decreasing? Well, the values for -2 that are smaller are over here, but we still look at it this way. As the x values increase, what are the y's doing? They're decreasing. Now I continue going from here, right? So from here to here, which is x values that are less than or equal to -2, we have decreasing y values. And those y values, get down, 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 down to -9, and then they turn back around and they increase again. So for the x values that are greater than or equal to -2, you have increasing y values, right? Increasing. Look at them. The y values are getting bigger. So what's the interval where x is increasing and y is also increasing? That's from x is greater than or equal to -2. And that was, of course, from lesson 2. We talked about that. Okay. Oh, lesson 1, excuse me, I'm sorry. Let's do this again. New parabola, new look. Here we go. Exercise 2. Oh, I'll do the table vertically this time, it seems. Or just horizontally, I should say. Okay, so let's take a peek. Well, it doesn't say that I need to start by finding the axis of symmetry algebraically. So let's just plug into our graphing calculator. So y equals, erase what we already had, and let's plug in. It's in standard form. Let's go. X squared minus x minus 2. Plug that guy in. Press graph to see it. Okay. Normal parabola, right? So far, so good. Nothing too funky. We can see our zeros. We can see our y-intercept. Okay. Let's take a peek at the actual points. Oh, interesting. Look. Let me pull this up so we have the axis of symmetry as much in the middle as we can. And I say as much in the middle as we can because if we look here, our minimum points are 0, -2, and 1, -2. Do you think that there's a point between these that goes even further down the -2? Yeah. And if we look back to our B term, it's an odd number. And we know when our B term is an odd number and we divide that by 2, then we're going to get a fraction. So there is a point here that is halfway between 0 and 1, aka 0.5, 1/2. So the way that we can get that point, we learned this back in chapter 3, but I'll do this again, is we go up to second and window. This is the table setup. So this is where our table starts at the point -5. And this is the next one, delta table. This is what my table is going by. And right now my table is going by integers. It's going by ones. But I want to see half points. So if I arrow down, so my cursor is down here, and I change this to 0.5, now my table is going to go by half points. So you'll notice that my x's are going to go -5, and then -4.5, and then -4, and then -3.5. So let's show that now on our table, second and graph. Now that I've changed it, look at that. Now I've got these halfway points, and what it shows me down here, I have to get a little further down because I want to be between 0 and 1. Look at this. It shows me that there's this point, 0.5, -2.25. That is my actual vertex. So if I plug in a parabola and I see that my axis of symmetry and vertex are between two values, that's how I can find what those are, the exact values. And I need that, the exact values. Okay. Now you'll notice that everything else I write down is just going to be the integer points. But as far as the actual axis of symmetry equation and vertex go, I need the exact values of that. Okay, so the rest of my horizontal table this time, because that's what I have room for, will be integer points. The first integer point I'm going to be able to fit, -3, 10. Then the next one will be -2, 4. And then the next one is -1, 0. Oh, that's a root. And then we've got 0, -2. Well, that's our y-intercept. And then we've got, this is where our vertex comes in, 0.5, -2.25. Then we can go back to 1. I wrote a little too big here. 1, -2, 2, 0. So another root. 3, 4. And I believe it's 4, 10. Yep, there it is. 4, 10. I wrote a little too big on there. Sorry about that. So actually, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just getting that point on there real quick. And I know you can't currently see my graph because my graphing calculator is too big, but I just wanted to make sure I got that point on there so I know. And then I can go from there. Negative 3, 10, 1, 2, 3, all the way up here. Negative 2, positive 4, 1, 2, 3, 4. Negative 1, 0, so there's a root. 0, negative 2, my y-intercept. This is where the 0.5, negative 2.25 comes into play. And then, of course, we head back the other direction. So 1, negative 2, back up to 2, 0, then 3, 4, and then that 4, 10 that I wanted to make sure I got. So see, we would have known, having connected these points right here, that this needed to be a U because it's a parabola. So we would have known that there was one more point slightly below these 2 points. Arrows right at the last points that fit, just like this. And let me label with my equation, y equals x squared minus x minus 2. So now let's label all of the pieces, and I'm going to label them on the table and on my picture. So of course, there's my y-intercept, 0, negative 2. Here's a root, and here's the axis of symmetry and vertex. And now let's label them here. Root, negative 1, 0, root, 2, 0, y-intercept, 0, negative 2, axis of excuse me, axis of symmetry, x equals 0.5 or 0.5 or 1/2, and vertex right on here is 0.5 comma negative 2.25. That's my vertex, and I got it all. Awesome. Let's answer our questions. What are the zeros of the quadratic function? Okay, again, we can either identify just the x values of the zeros, which are negative 1 and 2, or we can identify them as points, negative 1, 0, and 2, 0. Is the vertex a maximum or a minimum? It's a minimum. It's a bottom. It's a bottom of our parabola. It's the lowest point this parabola will go, and then it turns right back around. We could also see that by the fact that this is a positive x squared here, which means this is a smiley face parabola, because the positive, the smiley face, right? Which means it has a low point. Smiley faces have a low point. What is the equation of the axis of symmetry? X equals 0.5 or 1/2, same deal. And this is the one where we talk about from the x value of the axis of symmetry, does this increase or decrease, right? So what do the y's do from here? So I'll use this area right here with a different color. And from here, all the x values are getting bigger than 0.5. And over on this side, all the x values are getting smaller than 0.5. Okay, now let's just look at what y is doing as x goes, right? So here, y is getting smaller until it gets here. And then y gets bigger. So on this side, y is decreasing. And on this side, y is increasing. And this time, what was I asked? Over what interval for x is the quadratic function decreasing? Well, that would be x is less than or equal to 0.5. So when your x values are smaller than 0.5, your y values are getting smaller. And then once they get to the smallest point, they start to increase again. Your y values start to increase again. Okay, so there we go. All right. I am going to let you do all of this for this next one. All right, so for example 3, or exercise 3, I guess I should say, I want you to use your graphing calculator, get the table, label all of the pieces that we've been labeling on the table and on the graph, get the parabola on the graph, get the equation on the graph, and then answer A through E about this particular quadratic function. Okay, so pause it right here. Go ahead, get that going, and I'll come back with the answer momentarily. Okay, welcome back, Algebras. We can see that this was an interesting one as far as the zeros went. This was that example I was talking about where if you touch or cross the x-axis at non-integer points, we're looking at not necessarily having rational, certainly not integer roots or zeros. And so we can see that we do go from a negative a negative y value to a positive y value right in between here. We just don't know what that value is. And same over here, because it's not an integer, we don't know what that value is. So we can't directly identify the zeros without plugging into the quadratic formula or solving this by completing the square here. The rest all holds up. The y-intercept being the last number in the equation, right? That constant at the end. The axis of symmetry being x equals -3, the vertex being -3, +10. That axis of symmetry and vertex indicating a maximum point, right? It's the highest because we've got a negative x squared on the equation. Frowny face parabolas have a top, a maximum. And of course, we can tell that our intervals for increase, right? Our interval for increase is all the x values that are smaller than -3. That's where our y values are increasing, and then they turn back around. E was interesting just because I really can't put exact integers on this, but I did the best I could with what I knew was positive. From -6 to 0 are all positive values out of f of x. They're all positive y values. So I did the best that I could there, but I can't nail it down exactly because, again, I don't know what the roots are without using the quadratic formula. So because I don't know exact values for the roots, this is just my integer values that I know for sure are above 0 for the function, for y values of the function. Okay, and I base that off of my table, which I wrote down and still have on my graphing calculator on the screen. So you can also see this on the screen this way. Okay, so that they match up. All right, that's what I'm asking you to do on your homework for this. We do have another lesson for this. Again, because graphing functions is so important and using the graphing calculator, such an important thing to be able to do. But also making the connection as to what the roots are with what we did in chapter 8 and chapter 10. Okay, and so making those connections and identifying those, also very important. Making the connection with the algebraic way to get the axis of symmetry equation and find the point that is the vertex and identify if it's maximum or minimum. All that was information that I used to help me here. So we'll do it again, is the bottom line. Okay? All right, guys, this has been Chapter 11, Lesson 3, Day 1 notes. I will see you soon for Day 2. Again, make sure you're taking notes with the video and make sure you're practicing this with the homework and make sure you're asking me questions if you have them. Again, see you very soon. Bye, guys.